Here we go. We're on. We're live. Okay, first big idea. We're going to review the coordinate plane. Okay, what do you got to draw to make the coordinate plane? I heard it. 2 lines. What special lines are they? They have names. X and Y axis. X, Y. What are the 4 regions called again? Quadrants. Where do they start? Quadrant and counterclockwise. Very good. Quadrant 1. Now go counterclockwise. Quadrant 2. Keep going counterclockwise. And finish with quadrant 4. Okay. My question for this section is just tell me which quadrant am I in? If my X value is positive and my Y value is negative, do you remember how to plot points, I'm assuming? From the origin? What does that first positive mean? What direction am I going? Right. And then the negative? Down. Well, this one's in 4. Okay, let me challenge you. -3, negative square root of 5. And all I want to know is quadrant. Yeah. Don't let that square root scare you like it does a lot of people. Doesn't scare you. -3 means I'm going left. And that negative Y value just means I'm going down. Square root of 5 is like, what, 2 point something? I don't even know. 2 points, because 2 squared is 4. It's a little over 2, but 2 point something. So still down. So we're in quadrant 3. How about -7 and pi? Don't be afraid of pi. See it? Origin going left 7. Because pi is positive, we're going up 3.1415, you know. Still, we're in quadrant 2. 0, -10. Ooh, good one. Where am I? I'm not in a quadrant. So 0, don't go left, don't go right. -10 is down 10. We are on the y-axis. We're not in 3 or 4. So, trick question. Okay. Second part of this. If point AB is in quadrant 2, then where, meaning which quadrant, would A -B be at? He's quick. You would too. Okay, let's think about it. If AB is in quadrant 2, so what direction is A moving us? Left. So A is moving left. And then to get in quadrant 2, the B is moving us up. All right. So when A moves us left, a B moves us up. Now I'm saying go A, but then go opposite of B. So what way is A moving me again? Left. What's the opposite of going up? He was right. Quadrant 3. Where -A, B. Going back to the beginning now from there. So 1. Final answer. Because if A took me left, which way is negative A going to take me? Right. Because this means opposite of. Everybody wants to see a negative and think, oh, left. But no, no. A was left. So that means opposite of A is right. So this is pulling us to the right. B is still pulling us up. Right and up. Because you're so used to seeing with the negative left, but no, this positive A was left. Just to trick you a little bit. And our last one, where would negative A, negative B land? Hearing lots of 4s. Because we're going opposite of left, which means we're going right. Opposite of up, which means we're going down. Right and down. That's quadrant 4. Nice job. Next one. Next big idea. Pythagorean theorem. Okay. What kind of triangles did Pythagorean theorem work for? Just right triangles. Right and only right. Let's see if you remember the parts of the right triangle. Let's go A, B, C. And what did we call the side across from the 90-degree angle? Hypotenuse. Look at all the information that's still there. What about the two sides that came together to make the right angle? We had a special name for those, or called them something. The legs, the adjacent leg and the opposite leg, both legs. Leg and a leg. And then remember to name the sides. We could go with segments, like segment AB, but we could also use the letter across from it, like the hypotenuse, because it's across from vertex C, little c. And the leg down here, because it's across from vertex A, leg, little a. And then this leg here, because it's across from vertex B, leg, little b. Remember that? Now, what did Pythagoras find out about the relationship for these three sides? There was an equation he came up with and proved it. Everybody remembers that. A squared plus B squared equals C squared. That's true if the C is at the right angle. But if I was to put A down here and switch, then this doesn't work. So instead of A squared plus B squared equals C squared, I like to say leg squared plus leg squared equals hypotenuse squared. Because it's the hypotenuse by itself and the two legs hang out together. That's all just review from algebra. Nothing too challenging yet. I think I can fit this here. So we'll call this example 1. We got 5, 7, and an X. So because it's a right triangle and we have one side missing, we can set up Pythagorean theorem and crank through it to figure out that missing leg. In an exact form, not decimal. We're going to practice that too. So, how's Pythagorean theorem going to work for these three values? Who's got that for us? Yep, he set up 5 squared plus x squared equals 7 squared. Because this was a hypotenuse. But remember, hypotenuse stands alone, the two legs together. Now we just crank through it. 25, 49, do a little subtract. 24. I got down to x squared equals 24. Now what? Square root. Okay, back when life was easy, you could just type that in and get a decimal. 4 point something. 4.8, 4.9. I want you to be exact, though. Do you remember simplifying this? Where you looked for the biggest square number that went into 24. Do you recall? What's the biggest square number that goes into 24? 4. Do you agree 4 times 6 is 24? And we know what the square root of 4 is. Comes out as a 2. And the 6 stays under. Lots of exact in the upper level math. Good? Okay. Let me scare you a little bit. Well, quite a few. X 9 3 square root of 2. Okay, right triangle, we can still use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Yep, we're going to use parentheses. So, where's my hypotenuse at? The 9. There's my hypotenuse. That stays by itself. So that means our Pythagorean theorem is going to be x squared plus, I have to square this whole side, which is 2 numbers, so I'm going to use parentheses. You do need parentheses there. Equals the 9 squared. Okay. Remembering, no calculator needed here. X squared is going to carry. Okay. See this as 2 numbers multiplied together. It's 3 times the square root of 2. So we're allowed to distribute that in and square both of them, and then multiply the 2 results together. No problem with 3. What's 3 squared? 9. What is the square root of 2 squared? It's 2. Let me show you off to the side for people that aren't quite remembering that. So if you've got square root of 2 squared, I'm going to take baby steps so you can see it for this first one. That means square root of 2 times square root of 2. Multiply underneath together, I get square root of 4. Square root of 4 turns into 2.
If you have like anything squared, or the square root and it's squared, that means
Yep, so I was showing you why it is, but so now when you see a square root and a square, just know they cancel out and you get the number underneath. That's your shortcut to that, but I was just showing you how it got there. So what actually we have, after we square both numbers, is 9 times 2. What's 9 times 2? 18. No calculator needed. 81. And now we subtract. Um, 63. We're going to square root 63. But what is the square number that goes into 63? 4 is square but not big enough. 9 times 7. Oh, those multiplication tables from 4th grade. Dang it. Square root of 9 comes out as 3. 7 stays under. If a triangle was to have sides 5, 15, and 10, do those 3 sides form a right triangle? And you don't get to say yes or no. You must verify. Who's going to help us verify this? Good old Pythagoras. Great man that he was. Because if this is a right triangle, we have 2 legs and a hypotenuse. What's what here? What would be what? This would be the hypotenuse, and each of these would be a leg. So we're going to check the Pythagorean theorem to see if it comes out true. does the leg squared plus the leg squared come out equal to that hypotenuse squared? Let's find out. Here we go. 5 squared plus 10 squared. I'm going to put a little question mark above my equal sign because I'm not sure yet. That's what I'm questioning. Does that come out equal to 15 squared? Let's crank through this. 25 plus 100. That's 125. Over here, 15 squared is 225. Not even close. So those are not equal. So do we have a right triangle? No. Verified. All right, last big idea of the day is distance formula. Distance between 2 points in the coordinate plane. You've been cranking through this thing in Algebra 1. We did it in geometry a bunch, and I'm sure you did it a lot in advanced algebra. You should probably be able to recite this to me, but I'll review where it came from. If you have 2 points in the coordinate plane, say point A, which has its own ordered pair, x sub 1, y sub 1, then you've got a second point somewhere. It also has its own ordered pair, different from that one because it's in a different spot, x sub 2, y sub 2. You can use good old Pythagoras' theorem to help you get the distance formula. Because we are looking for this distance right here. Nice rain shower. We're looking for that distance. I'll call it D. Now you can make a right triangle out of this by dropping straight down and horizontal, making a nice right angle there. If we know those two dashed lengths, we can set up a distance formula with Pythagorean theorem. So think vertically. What I know about this point is that it's at y2. And this point down here is this y value here, y1. So let's say this was at 10, this was at -2. What would you do with those two numbers to get the length of this side? 10 and -2. How far apart are they? 10, -2. What's that total distance? 12. 10, -2, that's 12. What am I doing with those numbers to get 12? Subtracting them. I'm taking y2 and subtracting y1. So that would get me that vertical distance. Now I want to do the same thing horizontally. Well, what do I know about this horizontal distance? Well, it equals x2. This one equals x1. So how would I get that length? Subtract again. x2 minus x1. So there's leg 1, there's leg 2, there's my hypotenuse. So Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. But I'll start with the hypotenuse. So d squared equals this distance, which is x2 minus x1 squared, added to the other leg, y2 minus y1. And I don't want to leave it d squared, I want the distance. I want just d, so how do we unsquare something? Square root. Now it should look very familiar to you. Distance between 2 points in a plane is the square root of the x's subtracted and squared. Then add that to the y's subtracted and squared. Good. Okay. Do you want the assignment?
Sure.
You want to take a picture of it? You want to take a picture? It's quicker. I'll write it down. It's right there.
Thank you.
Where am I? Right here. Can you find the distance between -3, 5 square root of 2, and 6, 3 square root of 2? Why is that not coming in? That's better. Okay. Don't let the square roots bother you. It's just plug and chug math. Distance formula. Here we go. Doesn't matter which point you start with. Just make sure you're grabbing x with x and subtracting, and y with y and subtracting. So if I start over here, here's my x. This is 6. The other x is a -3, and I'm subtracting. So I'll go 6, subtract a -3, which is actually going to turn into adding. 3 square root of 2, subtract 5 square root of 2. No calculators needed. Okay, what is 6 subtract a -3? 9 squared is 81. Let's see. 3 square root of 2 subtract 5 square root of 2. Any guesses there? -2 square root of 2. See it? It's like x's. If I had 3x and subtract 5x, those are like terms, right? You get -2x. Same thing here. I've got 3 square roots of 2, subtract 5 square roots of 2. You just combine the numbers in front. 3 subtract 5 is a -2. -2 square root of 2. I have not squared it yet, because I wanted to take that little baby step there. But now we'll square that before we start adding over there. So remember before, like I said, you're going to square both numbers and then multiply them together. So what is -2 squared? -2 times -2, 4. Square root of 2 squared? 2. That makes 8. So we are getting the square root of 89. Anything go into 89? 88. Nothing obvious. 17. We might have hit a prime number. I'm going with prime. I'm going prime. Okay. Now we're at the last example. And this one here, you will have the opportunity to attempt it 3 or 4 times before it shows up on the quiz. For some reason, this one kicks butt. And I don't know why. It does. I'll put a little double star by it because it's kicks butt. Look back at this if you have to. But I am going to give you the distance between 2 points. And one of the points is 2, 3. And the other point, all you know about it is that the y value is 7. You don't know what the x value is. But you do know that the distance between them is 5. Can you find or solve for x? Love this problem, but for some reason it's a butt kicker. Don't even start that. I'm going to start that. What's going to help us out? What have we learned today? Which of the 3 big ideas are we going to use? Distance formula. Okay. I have the distance. The distance is 5. How do I get that distance of 5? Well, plug and chug. Square root. What does it say to do? Subtract your x's. What are my x's? 2 and x. So I can go x minus 2 or I can go 2 minus x. I like x minus 2. I like to keep the x first also. So I'm going to go x minus 2 squared. And we add. Now we do the same thing with the y's. 7 minus 3. Nope. It said the distance is 5. It is not squared. Right here. I didn't. I did the square root on both sides and dropped it. The distance is the square root. Yeah, we developed it. This was a development. This is what you really need. This is your distance. This was the development of it from Pythagorean theorem. Okay. All right. Now it's algebra. Where do we start this? Our goal is to solve for x, which is trapped under a square root in some parentheses under the... First I do what? Square what? How do I square x minus 2? FOIL. Not mathematically wrong, but that will take you into a brick wall if you FOIL this. Yep. If you FOIL this out, because if you FOIL it, you're going to have an x squared term and an x term. You've introduced a whole nother x. You don't want to do that. What do you want to do? This, like x squared minus 4? That is not legal. That's so bad. Square both sides. Is that legal? Because technically, I don't care what's under there. I've got a square root of something. But this whole side is a square root. And over here is a 5. So can I square both sides? That's legal. And the right move. It is. So it's going to eliminate that big ugly square root. That's amazing. So we've got 25. Over here, those cancel. And that's all that, everything else is still here. So I've got the parenthesis, x minus 2 squared, plus 7 minus 3 squared. Oh, I probably could have, would that have been legal for me to work that out? Yeah, I can, let's do that. So I'm going to leave everything else the same. I could have saved a step there and done that. So 7 minus 3, 4. 4 squared is, so I got a plus 16. Now what? Do not FOIL. That will get you the wrong answer every time. Subtract 16. I like that. Foiling is the avenue 10 people will still take after we've done this problem at least 4 times in class together. I don't get it. But somebody gives me the answer to making every kid do what I say, well, just education's going to be easy. But here we go. We got 9. Now what? Square root of both sides. I like that. But here is where another mistake will be made. On the right, not a problem. X minus 2. Okay, what does it mean to say take the square root of 9? What's that actually asking for? What number times itself gives me 9? Well, what number do you do times itself gives you 9? 3. Is there any other number in our world squared that gives you 9? There is another one. And now this is what, when you introduce that square root, you say, boy, what numbers squared give me 9? Positive 3 or negative. There are 2 answers coming off of this algebra move here. Positive or negative 3. This problem gets 2 answers at the end. Do some people get all the way through and give me 1? Yep. Where do they forget? Right there. So some will FOIL and get the whole thing wrong. Some will get all the way down to the second to the last step and just give me positive 3 and lose a point. So now we add 2. Add 2. We get 2 answers for x. x is 5, or x is... So, there are 2 points in the coordinate plane that are 5 units away from 2, 3. And I want to show you them so you can see where it came from. Real quick. You actually don't even have to graph this if you don't want to. So we had 2, 3. 1, 2, 3. Just a rough sketch. There was 2, 3. And then we had a point that was up 7. So my points were on this dotted line. So where was it going to be 5 units away? Well, we found one of them had an x value of 5. Over 5 up 7. That was a distance of 5. But then if you swing that over, there was that second one over here at -1, 7. That was also 5 units away. So there were 2 spots that accomplished what this was asking. Good? You will have one of these to practice. Make sure you look back. Your assignment then, page 11. Two through 42 even. Skipping. We're not going to make your life too miserable tonight. 8, 20, 32, 34, 36, and 38.